Alright guys, I went ahead and wrote some notes at the top. You might want to pause the video, that way you can get this written down, but I want to go through it really quickly. If the polynomial has this structure, in other words, if it is a plus plus or a minus plus, and like if it's x squared plus 2x plus 3, then you want to make sure that you can add your two factors to get the middle number. And if it's a plus plus, they're all going to be positive. If it's a minus plus, you're going to have both negatives. If you have a polynomial that looks like this, if it's a plus minus or a minus minus, then you're going to want to make sure you can subtract the two factors to get what's in the middle coefficient. If it's a plus minus, your biggest number is going to be positive. If it's a minus minus, your smallest or your biggest number is going to be a negative. Alright, so I'm going to try to get through this lesson kind of quick. They want us to factor these, so let's factor. X squared minus 1 is a perfect square. So I would factor that as 1 and 1. 1's going to be positive, 1's going to be negative. Alright, looking at this, once again, 9 is a perfect square, so 3x and 3x. 1's a perfect square. 1 and 1, 1's going to be positive, 1's going to be negative. Alright, let's factor this one. So factoring x squared, that'd be x and x. Once again, it's a plus plus, so I've got to be able to add whatever I factor 15 into to get 8. So hopefully you can think quickly. 1 and 15, I can't add those to get 8. 5 and 3, I can. So 5 and 3. And because it's a plus plus, they're both going to be positive. Alright, looking at this one, I have to factor this one. Once again, it's a plus plus. The only difference is here, I do not have a 1. So I'm going to factor 4x squared as 2x and 2x. And then I've got 15, I'm going to factor that as 5 and 3. And they are plus plus. X squared minus y squared, they're both perfect squares. So I'm going to factor them as x and x. One's plus y, one's minus y. Alright, and x to the fourth minus y to the fourth, once again, both perfect squares. So I'm going to factor it x squared, y squared, y squared. One's plus, one's minus. Alright, so you should notice the structure of each of the factored polynomials is the same. Or nearly the same, except for part B contains 3x in place of an x. Alright. D has a 2x in place of the x. So we have what we call the difference of two squares formula. Alright, the difference of two squares formula. So when I have, and I'm just going to use a and b right now, so when I have a squared and b squared, that means that I can factor it as a plus b and a minus b. So this is the difference of two squares formula that can be used to factor an expression even when the two squares are not obvious. Alright, so let's look. So write 9 minus 16x to the fourth as the product of two factors. Well, think about this. 9 is a perfect square. 16 is a perfect square. Alright, so I can look at this as 9 is 3 squared. And I'm going to put that minus. 16 is 4 squared. X to the fourth is x squared. So now I can write my factors. Alright? So it would be 3 minus 4x squared and 3 plus 4x squared. Okay? Notice one's plus, one's minus. Alright, so let's factor this one. Factor 4x squared y to the 4th minus 25x to the 4th z to the 6th. Okay, so this one may not quite be as simple, but let's look at it. Let's look at 4. 4 is a perfect square. That's 2. And remember, I'm squaring everything. So 2 squared. X squared is a perfect square, so that would be x. And y to the 4th is a perfect square because y squared times y squared would give me y to the 4th. Let's go ahead and look at our 25. What squared gives me 25? That would be 5. What squared gives me x to the 4th? X squared. And this one here, you've got to look at it and think about this for a second because we don't think of the number 6 as being a perfect square. It's not. But when you are dealing with multiplying exponents, you actually add the exponents. So x cubed times x cubed would give me x to the 6th. I'm sorry, y cubed, or this is z, cubed times z cubed would give me z to the 6th. So now I have figured out my perfect squares. Let's write those down. Alright? So I've got 2x y squared minus 5x squared z cubed times 2xy squared plus 5x squared z cubed. Alright? Now, I actually can look at this and I can see that they all have something in common. They all have an x in common. So I can pull out that x. Alright, I can pull out that x and see what they have in common. So I'm going to pull out an x here, and I get 2y squared minus 5xz cubed. And I'm going to pull out an x here, and I get 2y squared plus 5xz cubed. Ah, look at this. Look at this, guys. They're the exact same thing. The only thing that's different is the plus and the minus. So now I've got x times x, which is x squared, times 2y squared minus 5xz cubed times 2y squared plus 5xz cubed. Okay? And now I'm finished. There are 2 terms that are subtracted, and each term can be written as a square of an expression. Alright, so let's consider, I'm going to come over here to a separate sheet of paper, and let's consider 9x squared plus 12x minus 5. Okay? Now, let's think about this for a second. There are not perfect squares here. 9 is a perfect square, and so is x. So I can look at this and say, okay, this would be 3x, and I could square that. But then look at 12x. I cannot square that. There's no square there. But think about this. Can I multiply something times 3x to give me 12x? I can. I can multiply it times 4. And then I'm going to leave that negative 5. Alright, so now I know that 3x is common throughout. So what if we rename 3x? We'll rename 3x as u. All right, so when I rename 3x, look what I get. U squared plus 4u minus 5. Now, I can factor that. U and u, only one way to factor 5. And because it's a plus minus, I've got to be able to subtract to get 4. 5 minus 1 is 4. It's a plus here, so I want my biggest number to be a 5, or be a plus. Alright? So now, we were able to factor this. Alright? So by replacing u with 3x, let's look at our factors. 3x plus 5, 3x minus 1. So now I can factor this, and it does not require me to have to do a bunch of extra work. Alright, so let's factor this. I have 4x squared plus 4x minus 63. Alright, so let's think about, what can I do? 4x squared is a perfect square. That would be 2x quantity squared. 4 is a perfect square, but I want to get 2x in there. So what can I multiply times 2x to get 4x? Well, I can multiply 2. So 2 times 2x, and minus 63. Once again, I can replace my 2x with I can rename it. So rename 2x as u. So now I've got u squared plus 2u minus 63. I can factor this. U and u. Think about 63. It's a plus minus, so I need to be able to subtract my factors of 63 and get 2. Well, 9 times 7 is 63. So 9 times 7. 9 minus 7 is 2. And because this is a plus, I want my biggest number to be plus. Alright, so now replace your u with 2x, and I get 2x plus 9 and 2x minus 7. Okay? 12y squared minus 24y is minus 15. This one's a little bit more difficult. But look at this. Guys, I have a common factor here. I can pull out a 3. That leaves me 4y squared minus 8y minus 5. Now I see a perfect square. So 4 is 2 squared, so I have 2y. Think about this. What can I multiply times 2y to get 8y? I can pull a 4 out. Okay? Now, I can replace my 2y. So rename 2y as x. So I have 3 bracket x squared minus 4x minus 5. I can factor this as x and x. I want to subtract. So 5 minus 1 is 4. And this time I want my biggest to be negative. So this is my factor here. Alright, so now I can go back and replace my x with 2y minus 5 and 2y plus 1. And this is what it would factor as. Alright? Now, we can use the example of factoring x cubed, because not always am I going to have x squared or y squared or anything like that. But let's think about this. What if I have x cubed is equal or minus 8? And what if I tell you to factor that? we can talk about how to factor this. All right, now, suppose we want to factor x cubed minus 8. Do you see anything interesting about this expression? If you don't, I want you to think about this. I can rewrite this expression as x cubed minus 2 cubed. Think about that. 2 cubed is 8. So now I can guess a factor. All right? Now, more than likely you would guess x minus 2 or x plus 2 as possible factors. All right? So if I want to guess x minus 2 or x plus 2, because remember, we have now discovered that there's more than one factor to these. All right? Here's what I have to do. I have to do long division. So I'm going to do x minus 2. And remember, when we do long division, we've got to fill in those missing factors. So we're missing an x squared and an x. All right, so x times what gives me x cubed, that would be x squared. So I get x cubed minus 2x squared. Subtract. So 0 minus a negative 2 is positive 2x squared. And bring down my 0x. All right, so what times x gives me 2x squared? That would be 2x. So I have 2x squared minus 4x. Subtract. I get 0 minus a negative 4x, which is 4x minus 8. Bring that down. So what times x gives me 4x? 4. So 4x minus 8. Subtract. So we see that x minus 2 is a factor because it zeroes out here. There's no remainder. So I know that x squared or x minus 2 is a factor. Now, let's look at x plus 2. What times x cubed gives me, or what times x gives me x cubed? X squared plus 2x. All right. Subtract. 0 minus 2x squared is a negative 2x squared plus 0x. What times x gives me negative 2x squared? That'd be negative 2x. Negative 2x squared minus 4x. Subtract. All right, so I get 0 minus a negative 4, which is 4x. Bring down that negative 8. So what times x gives me 4x? That'd be 4. So 4x plus 8. Subtract. So negative 8 minus a positive 8 is negative 8 minus 8. That's negative 16. I do not zero out. So that is not a factor. So as a result, this is what I know. I know that I can factor x cubed minus 8 into x minus 2 times x squared plus 2x plus 4. Okay? Now, with that being said, that's as far as I'm going to go with it. All right? What if I want to do x cubed minus 27? Well, think about this. I can rewrite that as x cubed minus 3 cubed. And I would repeat that step. All right? So let's look at the last 3 examples here. A cubed plus 27. What would I do? Well, I can rewrite that as a cubed plus 3 cubed. So I would say, okay, what do I think my factor might be? So I could factor out maybe a plus 3. All right, so I've got to do my long division. So a cubed plus 0a squared plus 0a plus 27. All right, so what times a gives me a cubed? A squared. So I have a cubed plus 3a squared. Subtract. So a squared minus 3a squared is negative 2a squared. Bring down my 0a. So what times a gives me negative 2a squared? Negative 2a. So negative 2a squared minus 6a. Subtract. So 0 minus a negative 6 would be 6a. Bring down my 27. What times, I've messed up here somewhere. What did I do here? Oh, this should be 3, I'm sorry. So this is going to be 3. That was my fault. So I get 3 times 3 is 9. So this should be 9. So what times a gives me 9? So 9, that would be 9a plus 27, and it zeroes out. So I know my factor would be a plus 3 times a squared minus 3a plus 9. I would like for you to do number 3 and number 4 for homework. I want you to practice this. So how can I rewrite, and I'll go ahead and get you started. I can rewrite that as x cubed. 64, I got to think about what times what gives me 64. Well, it would be 4 cubed. All right? Here I'm going to give you a hint. Pull the 2 out, which would give you x cubed plus, look at that. All right, so finish these up for homework and make sure you turn them back in.